Good evening to you viewers and subscribers, and welcome to another video. My name is Belly1 Engineering, and as promised, I am going to talk to you about slab reinforcement plan and how to better able to understand your slab reinforcement. So in a previous video, I think I've mentioned to you that in a set of working drawings, there are two major aspects of that drawings. There's the architectural drawings and there's the structural drawings. Now, how this process works, the architect designed the building architecturally to have a certain flow, a certain aesthetics, and when that is concluded, the architect turn over those drawings to the structural engineer for the structural engineer to design the structural elements of that building. Whereas the engineer looks into the impended load that building is going to be subjected to. These are your live load and your dead load, your self weight of the building, right? And also your lateral load that is caused by earthquakes and your wind load. So the engineer designed those elements to carry those loads. Now, many architects won't tell you that the structural engineer does play the most critical parts in the design process, right? Because without that building designed structurally to carry all those loads, then the building won't stand up. You can design a building as pretty as you want it to be, but if that building is not safe, that building is no good. Because I know that you won't want to be lying down in the bed at nights and saw your slab roof come down on you. So the structural part of the drawings is a very critical part of the drawings. And in this topic, the slab reinforcement plan is a part of the structural elements of the building. The correct term to refer to it is the suspended slab, not the ground slab. It is suspended, so it is above. So it has to be designed to carry the loads that is going to be on that floor above. So it is a very critical part of the building. Apart from the foundation, your suspended flat slab plays a critical part of your building, because if the slab cannot carry those loads, that building is going to tear down, and we don't want that. So this presentation, I'm going to be talking to you and showing you how you can properly read those drawings. It is very important, and a lot of builders make a lot of mistakes because some of them will go ahead and splice, some of them go ahead and lap, but there's a way how to do it, and I'm going to show you in instances how you can do your laps and how you can do your splice. But when it comes to your slab detail, you do not want to slab, you do not want to splice, and you do not want to lap, especially in your tension zone. So after these few minutes, I'm going to be getting into the presentation. Thank you. Welcome to this segment, and I thank you for staying tuned. And in this segment, I'm going to be elaborating on the reinforced concrete slab, otherwise called your reinforced concrete deck. But in order to have a good understanding about the reinforced concrete slab, you must have a basic understanding of the behavior of concrete when it is subjected to loading. Now, as it is known that concrete is weak in resisting tensile forces, but strong when resisting compressive forces. So let me explain to you further by showing you this diagram that I've come up with. Now, as you can see in this diagram here, this is a cross section of a reinforced concrete slab. Therefore, this slab is being loaded uniformly. It is loaded uniformly. That means the load is transmitted uniformly right across the length of the cross section. And this broken line here, this broken arc line here, is the behavior of this concrete member when it is subjected to this UDL, this uniform distributed load. And as you can see, at the bottom fiber you have tension, and at the top fiber you have compression. Now, as I stated before, that concrete is weak when it is resisting tensile forces, but it is strong when resisting compressive forces. Always remember that. Concrete is weak in tension, but strong in compression. Okay? So that is why we put this reinforcing bar at the bottom of the concrete, not in the middle of the concrete, at the bottom of the concrete or close to the bottom, barring your concrete cover. And the reason we put the rebar at the bottom is that in that area, the concrete member is going to be the weakest. So that is why we put reinforcing bar in the bottom of the concrete member to resist against the tensile stresses that the concrete is going to be subjected to when it is being loaded. And this arc in red is the behavior or the tendency of the behavior of the concrete member when it is subjected to a uniform distributed load. And immediately to the right of this, it is the same situation, other than instead of being loaded uniformly, this cross section is loaded with a point load. And this is the behavior of the concrete in this instance when it is loaded with a point load. You're going to have something that represents a triangular deflection. So from this point here to this point here, at the center of this concrete member, your deflection in your concrete member here is going to be the greatest. So tension is going to be the greatest at the bottom, and compression is going to be greatest at the top. And there is a formula that we use in our engineering that we can calculate the maximum deflection at this point. So basically, the concrete member, as it is being demonstrated here, is just when it is being loaded uniformly or when it is loaded in a point load, just shows you the behavior. And I think this is a worthy knowledge for you as a builder or a contractor to know in order to appreciate that reinforced concrete slab. And you must try your best at all times to reinforce the slab as best as possible to withstand these loads. So that concludes this aspect of this presentation, and I am now going to take you what you should look out for in your slab detail. So therefore, I'm going to be talking to you about slabs, or otherwise known as your deck. Your deck slab. Some people call it slab, some people call it deck, same thing. In bridge it is known as deck, in building it is known as slab. So when we are talking about slab, there is one important factor that we must come to terms with, right? We have in our slab, in a building in particular, one-way slab and two-way slab. In a one-way slab, it means that the load distribution is in one direction. And in a two-way slab, it means the load distribution is in both directions, or in two directions. In a one-way slab, we reinforce in the shorter direction, because in the shorter direction, that is where bending is going to occur if the slab is loaded at the center. So as you can see now, we have two axes. We have the XX axis, and the YY axis. So if we should put a load at the center of the intersection where you have XX and YY, this slab or deck is going to be deflected in the XX direction. And that is why we put this transverse bar all along the X-axis to withstand that deflection. So the XX direction is the axis at which the slab is going to be the weakest. So we reinforce the slab with these horizontal bars from this point here all the way up to this point, right? And if you notice, the call out for this reinforcement is 13 millimeter half-inch bar MSB, which means mild steel bar at 225 millimeter, 9 inches on center as the main bar placed at the bottom. So that takes care of the bending in the weak direction. Now, when it comes to the YY direction, that is where the load is distributed. So in one instance, the transverse bar is carrying the load, and in the other direction, the longitudinal bar is distributing the load. And this is our longitudinal bar here. And if you notice, the call out for this longitudinal bar is half-inch MSB at 1 foot on center, right? At times, you will see this longitudinal bar being named your temperature and shrinkage. In the American system, this longitudinal bar is termed as the temperature and shrinkage bar. And the reason it is called temperature and shrinkage bar is that when the concrete slab or the concrete deck is heated, it is going to be expanded. It is going to be expanded in that its volumetric dimension is going to be increased. The slab is going to be increased in length, width, and thickness, the volumetric dimension. And when the slab is being cooled, it is going to contract or decrease in its volumetric dimension. So what the temperature and shrinkage bar does is to prevent the concrete member from shrinking past its original dimension, so that the concrete doesn't move from 5 inches or 6 inches as it was originally designed to 4 or 5 inches. So that is why it is called temperature and shrinkage bar. But in our system, the Jamaican system, it is called the distribution bar. right? So that pretty much takes care of our one-way slab. Now our two-way slab, and this is somewhat kind of different from our one-way slab. So in our two-way slab, we reinforce in both direction. We reinforce both in the XX direction and the YY direction. And if you look at the callouts, you will see that the spacing is the same. So this bar here, the callout is 9 inches on center bottom, right? And if you look at the callout for this bar here, we can see that the callout is 9 inches on center. So in the one-way slab, we reinforce in one direction, and in the two-way slab, we reinforce in both directions. Now, how do you know when you're dealing with a one-way slab as against a two-way slab? And there is a formula to derive or to know when you're dealing with one-way slab, right? And that is the ratio of the long side to the short side, meaning you divide the length by the breadth or width. And if that is equal or greater than 2, that means you're dealing with a one-way slab. And if you notice, the length of this slab is 24 inches, is 24 feet, and the width is 12 feet. So if you should divide that 24 by 12, you're going to be ending up with 2. And that means it would be in conformance with this formula here that you're dealing with a one-way slab. In a two-way slab now, if you look at the dimension for the two-way slab, you will see that the length is 12 feet and the width is 12 feet. So both the length and the width is the same dimension. So if you divide 12 into 12, you're going to get 1, and that is lesser than 2. So you're dealing with a two-way slab. So in a one-way slab, if the ratio of your long side and your short side is equal to 2 or greater, you're dealing with a one-way slab. And in the other instance, in a two-way slab, if the ratio of the sides is less than 2, that is a two-way slab. And this is critical to note when you're looking or you're reading your reinforced concrete slab or your reinforced concrete deck plan, because even though it is the work of the engineer to properly detail the slab, it is still worthy for the builder or the contractor or even the owner to know these things, and it will make your knowledge grow, and you will know what to look out for. So many engineers will tell you that a residential building is more complex to design than a commercial building, because in a residential building you have to take in consideration your one-way slab, your two-way slab. You still have to do it in your commercial, but in a residential building you have bedrooms of varying sizes, bathroom, living, dining of varying sizes. So you're dealing with a series of one-way or two-way slab. While in a commercial building now, you generally just have one slab dealing with, and it makes the design process a little bit easier. So this is a critical information, and you must take notes, especially when you're reading your slab reinforcement plan. As I said before, is the engineer responsibility to make your life much easier by putting the reinforcement in the correct place. So therefore, this knowledge is just added knowledge for you as a builder or a contractor to observe. and you can have a better appreciation for when you're dealing with your slab reinforcement plan. So that pretty much sums up the one-way and two-way slab, and now I can get into the main topic of discussion of how to read the reinforced concrete slab. And I think for this topic, it is a very wide topic, and I just merely just touch the surface. So I'm going to be uploading a part 2 to this presentation so that I can elaborate a little bit more. So that is it for this segment, and I will see you in the next segment. Thank you.